everybody, welcome back. Johnny B here with Devslopes.com, and we are continuing on with our Legend of Devslopes app. And just to recap, in the last video, here's what we did. We got our level all set up with the colliders, and we are able to now move around our player. And what we need to do now is we need to make it so that we can turn and have our player spin around and be able to move around, be able to turn, and we're also going to start adding in some animations. So let's get going. I'm just going to stop our play here. We need to work with something that is called a raycast. Okay, so what that does is you can kind of think of it like a laser pointer. Okay, and so the problem that we need to do is our mouse pointer works in 2 dimensions. But our game is in 3 dimensions, so we need a way to convert that. So what we're going to do is we're going to use the raycast, and like I said, you can think of it like a little bit like a laser pointer. And the starting point of the laser pointer is our main camera, okay? And the ending point is our mouse pointer. And so it's going to just shoot around wherever we point our mouse. And the raycast returns a hit when it makes a connection with what it wants to connect with. But because there are a whole bunch of things in our level, we got other enemies, we got houses, we got trees, etc. What we need to do is we need to specify what the layer is that we want it to hit. So what we're going to do is we're going to create a new mesh, and that's going to be our layer mask, and we're going to call it the floor. And we're going to do a couple of other things. And so let's go ahead and just dive into the code. And so I'm going to open up player controller, and I'm going to drag it on over here. And so what we need is we need to have our layer mask. So I'm going to say serialized field, private of type layer mask, and we're just going to call it layer mask. And that looks good. And so what we're going to do is back in the Unity editor, we're going to assign a layer mask to this variable, and we'll use that later on. All right, and so then we need one more variable. We're going to call it say private, and that's going to be a just a vector 3 position, and we are going to call it current look target, and that is where we want to be looking. Okay, and we're going to just initialize that to a empty vector 3 for now, because we don't know where to be looking when we first start up, so that's why we're just initializing it to 0. All right, so next thing we're going to do is we're going to create a new method. It's one that is a Unity default method, and it's called fixed update. So the difference between update and fixed update is the one that you want to use for physics objects. And since the raycast is indeed a physics object, we're going to be using all of this in fixed update. All right, so first thing we need to do is create a variable for our raycast hit. Okay, so that's just going to be raycast hit, and we are going to just call that hit. All right, and so that's just a variable for the point at which the raycast hits our specific layer mask that we're going for. Okay, and then we're going to just create the ray itself. So we're going to call the type and name it ray, and that is equal to camera.main.screen point to ray and input dot mouse position. All right, so we're creating the ray here, and so the ray goes from the camera.main, and we're saying screen point to ray, and where we want the want it to go to is the mouse position. Okay, so that's pretty straightforward. And then one thing we're going to add here is rays are invisible, and so it can be a little bit hard to tell where we're pointing and stuff. So we're going to add a little debug in here, so we can say debug.drawRay, and we're going to pass in the point in the world space where the ray should start, and that is ray.origin, and we're going to pass in the ray.direction and multiply that by 500, so that's the length of the ray, and we are going to give it the color of how about blue. That'll look cool. All right, so now we'll be able to see the ray. All right, so now we're going to say if physics.raycast, and so here we got a number of parameters that we're going to pass in. All right, so we're checking the raycast now, and we are going to pass in the ray that we created, and we're going to pass in the hit raycast, the raycast hit, and we're marking it as out so that we can use it at a later point if it exists. And we're going to pass in the length of the ray, and then we're also going to pass in the specific layer mask that we want to check for raycast hit points. And then we're going to say query trigger interaction, and we're going to say dot ignore. And so what that's saying is, you know, if there are other physics collision collider triggers, don't set any of them off. We're just going to be ignoring those. All right. And then inside of that, we're going to say if the hit dot point does not equal the current look target, set the current look target equal to the hit dot point. So in other words, if we're not already looking at where our mouse is pointed, make that point the current look target. Make that where we want to be looking. All right. So pretty straightforward if you break it down bit by bit. All right. So next up. So now we're going to do the actual bit where we do the actual rotation. Okay. So what we're going to do is we are going to create a new vector 3 that is target position, and we are setting that to the new vector 3 that is the hit point. Okay. So hit dot point dot x transform dot position dot y and hit dot point dot z. Okay, so all we're doing here is if there was a hit point on the layer mask from our ray, then we're setting that point to this new target position, and we're getting the x position from the hit, the z position from the hit, but the y position we're actually getting from the player object itself, because we want the rotation to continue to be at the same y level as the player itself. Okay. And then we are going to use what is called a quaternion, which is a real fun word. Sounds like something from a sci-fi movie. And the summary, quaternions are used to represent rotations. Okay, so we're going to say quaternion. And so we're creating a new quaternion, and we're naming it rotation. And we are saying quaternion dot look rotation, which creates a rotation with the specified forward and upwards directions. And so we're going to say look rotation, and we are going to pass in the target position variable that we just created and subtract that from the transform dot position. Okay. And then we are going to say transform dot rotation. So now we're actually going to set the rotation to this quaternion, and we are going to lerp it, which remember is an interpolation between two vectors, and in this case we're going to be lerping a rotation. Okay, so lerp, and we're going to pass in the current rotation of the player, then our target rotation, or the one that we just created right here, that rotation, and our good old-fashioned time dot delta time, and I'm going to multiply that by 10f. And so that 10f right there, that just controls how quickly our turning is, and we can play with that here in a minute, and I'll show you the results of that. Okay, and you know what, I think that should actually do it. We got a little bit to do in the Unity editor, but just let's run through this one more time from the top. So we create a hit point variable, and this is the where the raycast is actually hitting the layer mask that we're going to define in a second. Actually, you know what, let's do that first, and maybe this will make a little bit more sense. So back in our scene, we are going to create that floor, the layer mask that I've been talking about. So here in the hierarchy, go ahead and close the sample scene and go to create or a 3D object, and we are going to create a plane. Okay, and so there it is. Going to set the position to zeros. Let's see here. And we don't need a mesh renderer. In fact, I'm going to delete that, remove component, and let's see here. Let's just drop this down here to the level of the floor, and we are going to make this much bigger, about 10 by in the 10 in the scale it by 10 in the X and 10 in the Z. Let's see if that's big enough, and go ahead and move it a little bit that way, but I think that should be good. And so this is the floor. This is the layer mask that I've been talking about. So when, let's see if we can scoot over here and find the camera. So here we're going to have a raycast that is shooting from the camera to our pointer position. So down here in the game view, when I'm moving around, and we have a raycast shooting from the camera down to the floor, wherever it hits on this layer mask, that is the raycast hit. Okay, so let's open back up our player controller again. And so we got our raycast hit. That's where the raycast intersects with the layer mask. We are creating a ray from the main camera to the mouse position. We are setting up a debug draw ray so that we're able to visualize the raycast. And then we're saying with the physics.raycast, this is what actually sets up the raycast, and we pass into it a ray that we created, the hit, and we mark it as out so that we can use it right here, you see. The length, the layer mask that we are looking to intersect with, and we are ignoring any other trigger interactions. And then we set the current look target to the hit point if we're not already looking in that direction. And then we go ahead and perform the rotation right here. And so let's go ahead and finish up here in the Unity editor. We need to select our where did our oh, got it put right here. Okay, so that ended up inside of the scene somehow, and we want that out here. All right, so that's there, and we're gonna rename that to floor. Okay, and now we need to set its layer to floor, but we got to create it. So layers are a way to separate physics objects. And so for instance, here we have a raycast that is being cast down, and we want to make sure that it only interacts with the floor itself. So we're going to create a layer, and so just go to add layer, and then these are the reserved ones. So starting at 8, we can call this floor. And then that doesn't actually set it, all that does is create it. So we have to go back to floor and then select the layer and select floor. Perfect. All right, so now we have our layer mask that is called floor. We've set the layer to floor. And now all that's left is to go to our hero script, our player controller script, and choose layer mask and set that to floor. And that should do it. Go ahead and save it and run. Hey, check it out. So now we're turning, we're moving, we're turning. And if you look in the scene above, you can see that blue raycast that is moving around. So how cool is that? So now we got movement and we have turning. But if you look at us, you know, we're just moving. You know, we're not moving our legs. We have no animation going on. So let's go ahead and fix that right now as well. So what we're going to do is now we're going to work with an animator controller. Our hero already has an animator, but we need a controller. All right, so we're going to go down here to our assets and create a new folder, and we're going to call this animator. All right, and inside animator, go to create and animator controller. All right, and we're going to call this hero AC, AC for animator controller. All right, and then up here, if you don't already have the animator window, that can be found here in the window, okay? And when we open it up, you'll see we have any state and entry. And so how the animator works is it's a state machine, meaning that you can think of it kind of like a flow chart. And so the animation states that we want, at least to start out with, is going to be idle and walk, okay? So let's go ahead and add those animations to our animator, okay? So we're going to go to models, and we're going to select our hero. And down here, we have our animations that we spent a good chunk of time in the second video getting all set up, all right? So what we're going to do is we are going to grab idle and walk. Okay. And so the first one that we drag in is automatically set as the entry state, meaning that whenever the game starts up, that is going to be the first state that it enters, which for us is fine. You know, right when the game starts up, we don't want her to be running around or attacking or anything. She'll just be kind of standing there, bobbing around. All right, so that's good. And so then if we want to transition to other animations, what we can do is we use these parameters here and use transitions, okay? So we're going to create a parameter by clicking right here under parameters and then this plus button. And we're going to say, and we're going to make this a bool. You can have different types of parameters. They can be floats, ints, bools, or triggers. So a bool can be set true and false. The trigger is kind of a one-time thing. It's just set, and then you have to set it again. All right, so we're going to say bool, and we're going to call this is walking, okay? And then we're going to make some transitions between idle and walk. So we're going to right-click and say make transition over to walk. And we're going to make a transition back from walk to idle. And then we are going to go ahead and click this transition here, the button on the bottom, from idle to walk. And we're going to take a look at our settings, okay, and our conditions. And so what we got here is these are the conditions, and we can add conditions for the transition to occur. And so what we want is to check if is walking, the bool is true, then we're going to transition from idle to walk. And vice versa, on this top transition from walk to idle, if the bool is walking is false, then we're going to transition back to idle. Okay, so that is Good. And we can already see a little bit of how this animation is going to be working just by pressing play right now, because we set up an entry state. So when we press play, she should be in idle state. All right. So let's see if I can zoom in here and see if she is in idle. It doesn't actually look like she's in idle, and I think I know why. Is because if we go and look at hero, we have not set a controller for our animator. Okay, so for any animator, we also need a controller. So I'm going to click on the right circle, or on the circle select button next to the controller, and I'm going to select hero AC. And then I'm going to play again and see if that works. All right, so now you can kind of see her hair bobbing, her head moving a little bit. So now we know that we are in idle. So that's looking good. All right, so now let's go ahead and set up the code to determine whether we are walking or not. All right, so let's jump into our player controller. I'm going to click on hero and open up our player controller script and drag that back over here. So to work with the animator, we need a reference to it. So up here, we're going to say private animator. We're going to call it anim. And then in start, we are going to get a reference to that. We're going to say anim is equal to get component of type animator. So now we have a reference to it. And in update, what we can do is we can say, so we have our move direction, so we can check to see if it is 0 or if we're moving or not. And so what we can do is we can say if move direction is equal to vector3.0, or in other words, if we're not moving, then anim.set bool is, and then is walking to false. So what we did here is we are checking to see if we're moving, and if we're not, whoops, need to fix that, is walking. Then we are going to grab our animator controller and we are going to set a bool. And the bool that we are going to set is the isWalking parameter that we created in our animator controller, and we are going to set it to false. Okay, and then we're going to say else anim dot set bool, and we're going to set the isWalking bool to true. All right, so just a little bit of quick logic to do a check to see if we're walking, and if we are, then we're going to set the animation parameter boolean isWalking to false or to true, and if we're not walking, we're going to set it to false. Okay, so go ahead and save that. Go back to our Unity, and let's go ahead and play that and see if our animations are working. All right, so this is another cool thing. During gameplay, you can see the animation states and their progress for each animation state. So I'm going to start moving, and we should transition to walk. And sure enough, there we can see we are going really fast. I think we need to adjust our speed. So I'm going to go down to move speed down here in the player controller and set it to maybe 6. Let's see what that's like. Yeah, that's a little bit more reasonable. All right, and if you can tell, we are moving our feet, we are running around, and if you look in the controller, the animator controller up top, whenever we stop moving, the idle takes over, and when we start moving, the walking takes over. So that is really cool. All right, awesome. So I'm gonna zoom back out here. So what else can we do with our animator controller? We know we have some cool attack movements, so let's go ahead and add those as well. So go back to our models folder. We're going to have our hero selected, and we are going to drag in double chop and spin attack. Okay. I'm gonna arrange them like that. And we don't need any transitions to these. We're just going to just play them directly, but we do need to have some transitions back to both idle and walk. Okay, so after we finish our attack, we're going to need to return back down to idle or walk, depending on what we're doing. So from let's start with spin attack. From spin attack, I'm going to make a transition to idle, and from spin attack, I'm going to make a transition to walk. And just like we did with these two, I'm going to select the transition, go to the conditions, and add a condition for is walking. And so this one is to idle, so is walking should be false. And then for this transition, I'm going to add a condition, click on the plus, and is walking should be true. And then do the same for double chop. So right click, make a transition to idle, and let's see if we can select it. All right, looks like we got it selected. And conditions is walking is false. And then from double chop to walk, the transition should be, or the condition should be, is walking is true. All right, so that looks good. So now we have those set up, but how do we trigger those? How do we get those working? So let's go ahead and jump back into our code again. I'm gonna open that back up. And here in update, we are going to say, so we're going to use our mouse button for to trigger our attacks. All right, so we have two attacks, so we can assign one to the left button and one to the right button. Okay, so I think that'll be a pretty good way of doing it. So we're going to say if input dot get mouse button down, and 0 is the index for the left button. All right, so we're going to say, if we do that, we're going to say anim.play, and then we simply pass in the name of the animation. Okay, and then we're going to say if input dot get mouse button down is equal to 1, so that's the right mouse button index. Then we're going to say anim.play, and that is going to be spin, oops, we got to put that in quotations, and that is spin attack. All right, so let's go ahead and save this and see if that works. Just gonna move this back over here and press play. All right, so we're running around or walking, and then I'm going to go ahead and press our left mouse button, and yeah, all right, so awesome, we are double chopping. Check out here in the animator controller, when I click, the animator goes to the double chop, and then right back to idle if we're not moving. So what happens if I'm walking and then do the double chop? Then it goes right back into walking just like we expected. Now right click for the spin attack. Nice. Perfect. All right, so that is working out very nicely for our attacks, and now we're moving around, and you know, this is already coming along very nicely, and it looks really great. All right, so just to recap what we did in this video, we set up a raycast system so that we are able to turn our player, and then we also set up the animation system. We learned about some of the state transitions. We have an entry state, which is the first animation that will begin playing when the game starts up. We learned about how to add parameters and how to use them in transitions, and then how to play animations directly as well. And so this is coming along very nicely, and I'm excited how this is turning out. Hope you guys are as well. And so this is Johnny B with Devslopes.com, and we will see you in the next one.